All right, we're going to work on writing the following in their logarithmic form. So you can see that we have our exponential form where we have our answer is equal to the base is 2 and the exponent is our 5. So if we turn that into its exponential or its logarithmic form, we start with the exponent. So the 5, the exponent, is equal to the log of the base, or log with a base of 2, and the answer was 32, and that becomes what we call the argument. So there it is in its logarithmic form. Try the next one, and if you do, you should have the exponent, which is equal to x. So x is equal to the logarithm with a base of 3 of 125. And the last one, the exponent would be equal to the logarithm of 1.015 with a base of 2. Okay, and any one of these could have brackets around that argument. That whole thing is our argument there. Sometimes you'll see it with brackets, sometimes you won't see brackets. All right, now we need to work backwards here. So it's really important that you can go back and forth between the exponential and the logarithmic form, okay, because that will help us solve various equations. So in example C, this one, we can't solve for x because it's an exponent until we write it in its logarithmic form. And then we'll learn how to use the calculator for this. All right, write the following in exponential form. So remember, this represents the exponent, and here is your base. The base is 7. So we have 7 to the exponent of 15 would equal x. So by changing this logarithmic equation into its exponential form, I now have solved that for x, and 7 to the 15 is just a really huge number, but that's what x is equal to. All right, next one, our base was the 4, so 4 is our base. The exponent is the m, and that is equivalent to n. So n is equal to 4 to the exponent m. The next one here, the base is b, the exponent is the 16, and the answer was 4. So b to the exponent 16 is 4. Now by changing that one into its exponential form, we actually could solve that for the b. To get b by itself, I would undo the exponent of 16 by taking the 16th root of both sides. So b, if I was asked to solve it, b would equal the 16th root of 4, whatever that is equal to. All right, now we're going to actually start using our calculator on the next page here. Evaluate the following with your calculator. Now, this has a base of 10, so we're doing the log of 15 with a base of 10. So this is saying, well, what exponent am I going to put on 10 to get an answer of 15? That's really what we could be thinking with this question. That's really what it's asking us to do. 10 to what exponent, that's a question mark, is going to give us an answer of 15. Well, on your calculator, you should have a button that says log, log. And depending on your calculator, there's going to be a couple different ways you could do this. One type of calculator, I'll just put A, some of you are going to hit the log button. So you're going to use that log button first, and then you're going to hit 15, and then you hit equals. And that's a button, so it's in the square. So some of your calculators will work that way. I have an older calculator. My calculator, I actually have to put the argument in first. I put my 15 in first, and then I hit my log button. And I don't even have to hit equals now. It just tells me what the answer is. So it just depends which calculator you have, which one you're going to get there. And if you do put that in your calculator, and I'm just doing that right now, I got approximately equals approximately 1.1761. Okay, and it kept going, but that's approximately what we get there. All right, so that's a base of 10. Now that log button on your calculator is implied to have a base of 10. So when the base of a logarithm, so I'm right here, when the base of a logarithm is 10, it is known as the common logarithm. now. So lots of applications in real life, lots of science things that they use logarithms for. They do work with a base of 10. So we do have that button on our calculator. Done. You just put in your argument, you hit log or vice versa, log and then your argument and equals. All right. When there's no base written, like in part B, that is your common logarithm. When no base is written, that is assuming a base of 10. So you're just going to hit your log button, your 22, your equals, or 22 and then log, and you'll get your answer there. But I do want to write that in. When no base is written, when no base is written, it is assumed to be a base of 10. Be a base of 10. So that's equivalent. That could be the same as the log. We don't, it's just mathematicians being efficient, not lazy, efficient with their time. All right, so that is the same thing, which when you put that in your calculator, 22 log for me, because I've got the other calculator, the older one, 1.3424 approximately. Okay, it kept going, but that's roughly what it is. So that means 10 to the exponent 1.3424 should give you an answer of 22. All right, the last one, 125, hit the log button. That gives me approximately 2.0969 on that one. So that's approximately equal to that. So again, 10 to the exponent of 2.0969 gives you an answer of 125. And that makes sense because 10 squared would be 100, so it's going to take a little bit more than an exponent of 2. Now, the next question says, how do we evaluate logarithms if the base is not 10? So we're actually going to learn that on the next lesson. For now, this is to come later, to follow later. Okay, we're going to do that. Dun, dun, dun. Keep you in suspense. Some of your calculators, some of the new calculators actually have a log button and it will have this, and you actually can insert whatever base you want and then your argument goes here. So some of you will have a calculator that can deal with that, but I really want you to get used to working with the laws that we're going to use eventually. So you've got some duotang work to do now, and then there's an investigation again to do after you're finished that.